Very good morning, all. Today we are going to see a problem of Thevenin's theorem. Take down this problem. Use Thevenin's theorem to find the current to 6 ohm resistor as shown in the figure. So here the circuit is given. This here it is 2 volts. Here it is 3 volts. In between 6 ohm resistance is there. Here also some two resistance are given. That is 4 ohms and 5 ohms are given. So they clearly given this point is A and B. Okay, this point is A and B. Here we need to find out the current through 6 ohm resistor like that clearly given. So what are the questions that we have seen in the previous problems? The all resistance will be in the last load resistance, so it is very easy to solve. So here somewhat they twisted the question like this. They asked to find out the current to 6 ohm resistor that is in between, and this two points are A and B. So solution: first open circuit the terminals A and B, and short circuit the voltage source. Okay, voltage source and open circuit the current source. So current source is not there, so you just we need to short circuit the short circuit the voltage source. So to find out RTH, what we need to do is we need to short this two circuits. Okay, and we need to open the load terminals. Load terminals we opened. Here we need to find out what is RTH. RTH we need to find out. So if you see this 4 ohms and 5 ohms are in parallel, so we need to find out the RTH. So RTH is equal to 4 into 5 divided by 4 plus 5. So we'll get the RTH as 2.22. Next, we need to calculate what is VTH. So how to calculate VTH in the sense here, yeah, here one voltage source is there, here one voltage source. So this is open circuit. At last only we need to calculate. So this 4 ohms is there, this 5 ohms is there. By using the this analysis or loop analysis, we'll easily find out the is the current. So so here, if you see here, current analysis. So it is 4 into I plus 5I. Okay, this is positive to negative, so it is positive. So plus 3 here minus 2 plus, so it is minus 2 is equal to 0. So 9I is equal to minus 1. I is equal to minus 0.11 amperes. That means the current is not flowing like this. Current is flowing like this in the reverse direction. Okay, the reverse direction current is flowing. So the current we calculated, we need to find out VTH. Okay, here we need to find out the VTH, that is open circuit voltage, or VTH. And here we need to find, because this is the open circuited path. No? So in between this, we need to find out the open circuit voltage. So in between we need to find out the. So here what we can do is. Here what we are doing is we are applying the KVL in the loop 1. Again, similarly, we are applying the KVL in the loop 2 also. Either any one you need to do, okay? Because this side if you do also, you get this side if you do also, you get this. Okay, so the current we calculated as 0.11. No? So that current is flowing not like this, because it is minus. No, so minus means it is flowing like this. So 4 into 0.11. So that means the current is flowing in reverse direction. No? So 4 into 0.1 kVL plus 2. Okay, plus 2. So voltage source is directly vector. So plus 2. Here, if you current is flowing like this direction. Okay, so because we got negative, no, so current is flowing like this. Okay, previously we considered like this, but due to the answer we got is negative, so we are considering the current like this. That is, the current is I. So I is nothing but what? I is 0.1. Okay, 0.1. So that is in minus, so we consider like this. Okay, not like this. Like this only usually we'll consider, but if the answer is we got is minus 0. So we are considered like this. So 4 into 0.1 plus 2. So again, plus 2 minus current is flowing to plus 2. Here again it is current is flowing like this. Again it is minus 2. So minus 2 versus minus VOC is equal to 0. Then you can easily find out VOC. So VOC from this you can easily find out VOC is 2.44 volts. Either you can apply in this loop or this loop. Just for calculation purpose, I applied to two loops. But in your while solving the problem, you no need to go for two loops. Either one loop is enough. So again, I have applied a KVL in the loop 2 also. KVL in the loop 2 also. Okay, the current is flowing like this. As because the current direction what we got is minus. So the current we are considering like current is flowing like this. Current I is equal to flowing like this. So I is equal to you already we calculated. This is minus, so it is in reverse direction. So that is nothing but 0.11. So here if 5 into 0.11, so this direction is positive to negative, that is plus VOC. Again it is coming like this. It is minus 3 is equal to 0. Then VOC is equal to 3 minus 5 into 0.11. So while simplifying, we got 2.45 volts. That is approximately equal to 2.4, 2.44 and 2.25 are almost same. So we got the open circuit voltage or VTH as 2.44. So now it is clear, no? So here now VTH we got, RTH also we got. Now in either way we are getting the same answer. So at any loop analysis enough for finding the any one loop analysis enough for finding the VTH as I said. So now VTH is there, RTH. VTH is 2.44. RTH what we calculate is 2.22 volts. And the open circuit voltage that voltage we open that resistance is 6 ohms. So that also we are considering this. Here we need to find out the IL. Okay, current across this point A and B, because we are considering this point as A and B, this point as A and B, A, and this point as B. Okay, this point as B. So here IL is nothing but B divided by total resistance. That is two resistance are connected in series. So 2.22 plus 6. So 2.44 V by R. So 2.44 divided by 2.22 plus 6 is equal to 0.2968 amperes, or in other terms 296.8 milliamperes is the IL, that is current flowing through the A and B. That is the answer for the particular circuit shown in the figure. Yeah, this is the answer. So current flowing between the 6 ohm resistors is whatever we calculate. Okay, so here a small recap. Here the load resistance is given in the center. Usually it will give in the last. So center will also no issues. So points also given A and B. So simply what we are doing is we have open circuit and short circuit voltage source. We are going to find out the RTH in the center point, because this only we open circuit. No? Next we need to find out the VTH. For VTH, what we did is first we calculated the current. After that current, we calculated the by using KVL. We calculated the B, that is VTH we calculated, and from that VTH and RTH and also load resistance, we calculated the what is the current flowing in the particular circuit. Okay, so because here you see, here you need to open circuit, that is here this is nothing but a open circuit voltage. Okay, open circuit voltage in this point center we are going to find out the open circuit. So we are calculating in the center of the line. So that's why we are applying the okay. So here we are considering VOC and VTH. Here we are applying the we are calculating the VTH, and from that VTH we are calculating the IL in this particular. Thank you.